Okay, so once again, good morning. So good day. Our topic for today this time is correlation coefficients. No, the correlation coefficient are used to measure how strong a relationship is between two variables. There are several types of correlation coefficient, but the most popular is Pearson's correlations. No, the Pearson R is a correlation coefficient commonly used in linear regression. So if you are starting out in statistics, you'll probably learn about Pearson R first. Then in fact, when anyone refers to the correlation coefficient, they are usually talking about persons actually. Okay, so correlation coefficient formulas are used to find how strong a relationship is between data. And the formulas return a value between -1 and +1. Okay, so to give us more details about the topic, let us all welcome our presenter.
Hello, good morning, Dean. Good morning, everyone. I'm here to report about coefficient. Wait lang, Dean. Stop share ko lang. Naglo ko yung ano. What is a correlation coefficient? Correlation coefficient are used to measure the strength of relationship between two variables. Pearson's correlation is one of the most commonly used in the statistics. This measures the strength direction of a linear relationship between two variables. Values always range between -1, strong negative relationship, and +1, strong positive relationship. Values at or close to 0 implies a weak or non-linear relationship. Correlation coefficient value less than +0.8 or greater than 0.8 are not considered significant. There are several types of correlation coefficient, but the one that the most common is the Pearson correlation. This measures the strength and direction of linear relationship between two variables. It cannot capture non-linear relationship between two variables and cannot differentiate between the dependent and independent variables. A value of exactly 1.0 means there's a perfect positive relationship between two variables. For a positive increase in one variable, there is also one positive increase in the second variable. A value of -1 means there are a perfect negative relationship between the two variables. This shows that the variables move in opposite direction for a positive increase in one variable. There's a decrease in the second variable. If correlation between two variables is 0, then there's no linear relationship between them. The strength of relationship varies in degrees based on the values of correlation coefficient. For example, a value of 0.2 shows there's a positive correlation between two, but it is weak or unlikely unimportant. Analysis in some field study do not consider correlation important until the value surpasses at least 0.8. However, a correlation coefficient with an absolute value of 0.9 or greater will represent a very strong relationship. Investors can use to change the correlation statistics to identify new trends in financial markets, economy, or stock prices. Correlation statistic and investing. Correlation between two variables is particularly helpful when investing in a financial market. For example, correlation can be helpful in determining how well a mutual fund performs relative to its benchmark index or another fund or asset class. By adding a low or negatively correlated mutual fund to an existing portfolio, the investor gains diversification benefits. In other words, investors can use negative correlated assets or securities to hedge the portfolios or reduce market risk to volatility or wild price fluctuation. Correlation statistics also allow investors to determine when the correlation between two variables. For example, if the bank stocks typically have a high positive correlation to the interest rate, since loan rates are often calculated based on the market interest rates. If the stock price certain bank is falling while the interest rate are rising, investor can lead to something's wrong with the particular bank. And if the stock price and the other bank sector are also rising, investors can conclude that decline of outlier bank stocks is not due to interest rate. Instead, the poorly performing bank is likely dealing with an internal or fundamental issues. What is meant by a correlation? A correlation, sorry, how do we calculate the correlation coefficient? The correlation coefficient is calculated by first determining the covariance of variables and then dividing the quantity by the product of those variables standard deviations. It is widely used statistical measure in investing to play a very important role in areas of portfolio composition, quantitative trading, and performance evaluation. Some portfolio managers will monitor the correlation coefficient of individual assets in their portfolios in order to ensure total volatility of the portfolios maintained within acceptable limits. Similarly, analysts will sometimes use correlation coefficient to predict how a particular asset will be impacted in the change of external factors such as price of commodity or interest rate. The correlation Pearson, correlation between sets of data is measured how well they are related. The most common measure is the Pearson correlation. The full name Pearson product moment correlation. It shows the linear relationship of two data. The Pearson coefficient is mathematically correlation coefficient representing the relationship between two variables denoted as x and y. Pearson coefficient range from +1 to -1. +1 representing the positive correlation and the -1 representing as negative correlation, and 0 is no relationship. So here's an example po ng Pearson coefficient ng Pearson. Then the N stands for the number of pairs, the sum of x and y, the sum of product of paired score, sum of x, the sum of x scores, sum of y scores, then the sum of squared x scores, then the sum of squared y scores. So dito sa sample po, pag may mga digits na po ng Pearson ano po. So yung sinasabi kanina na pag 0.08 greater than 0.08 means there's most likely the two sets of data are linear. The types of research question Pearson correlation can examine. First is if there's a statistical significance between relationship between age as measured in years, height measured in inch. In the relationship between temperature measured in degrees Fahrenheit or ice cream sales, and is there a relationship between job satisfaction as measured by the JSS income or measured in dollars? The benefits of Pearson coefficient for an investor who wishes to diversify a portfolio, the Pearson coefficient is very useful. Calculation from scatter plots from historical returns between pair of assets such as equities, bonds, equities, commodities, bonds, real estate, etc. Or more specific, the assets such as large cap equities, small cap equities, and debt emerging market equities will produce. Pearson coefficient to assist the investor in assembling a portfolio based on the risk and return parameters. However, that the Pearson coefficient measures correlation is not a causation, which means that one variable produces a result in other variable. If a large cap or small cap equities have a coefficient of 0.8, it will be known as what caused the relatively high strength of association. I think Here's the potential problem with the Pearson correlation. Pearson correlation is not able to tell the difference between dependent variables and independent variables. If you're trying to find the correlation on a high calorie diet or diabetes, you might find the high correlation of 0.8. However, you could also get the same result with the variable switch around. In other words, you can say that diabetes causes high calorie diet. That's obviously no sense. Therefore, researchers have to be aware of the data you're plugging in. In addition, the Pearson correlation will not give you any information about the slope of line. It only tells you whether there is a relationship. For Pearson correlation, both variables should be normally distributed. Other assumptions include linearity and homoscedasticity. Linearity assumes the straight line between each of the two variables, and the homoscedasticity assumes that the data is equally distributed about the regression line. The Spearman-Rank coefficient of correlation is a non-parametric measure of rank correlation, statistical dependence of ranking between two variables. Name after Charles Spearman is often denoted as a Greek letter rho, or is primarily used for data analysis. In statistics, non-parametric methods, the Spearman-Rank correlation coefficient is measured on the relationship between two variables when the data is formed and rank orders are available. Spearman-Rank correlation test does not carry any assumption about the distribution of data, and it's appropriate that correlation analysis when the variables are measured in a scale that is at least ordinal. So here's a sample ko ng Spearman correlation of Spearman. The rho or the Spearman-Rank correlation, the difference between the ranks of corresponding variables, then the n is the number of observations. So it's an example po na Spearman-Rank. Types of research question as Spearman correlation can examine. Is there a statistically significant relationship between participant level of education or their starting salary? Is there a statistical significant relationship between a horse finishing position as the reason? The assumption of Spearman correlation are that data must at least ordinal or scores on one variable must be monotonically related to other variables. That's all po. Thank you po.
Okay, I just want to add some additional inputs regarding correlation coefficient. Again, correlation between set of data is measured of how well they are related. The most common measure of correlation in statistics is the Pearson correlation. So, actually the full name is the Pearson Product Moment Correlation, or the PPMC. So it shows the linear relationship between two sets of data. So in simple terms, it answered the questions: can I draw a line graph to represent the data? So two letters are used to represent the Pearson correlation. The Greek letter rho, no, yung P, for a population, and letter R for a sample. Okay, so what are the potential concerns now with Pearson correlations? The Pearson Product Moment Correlation, or the PPMC, is not able to tell the difference between dependent variables and independent variables. Let's say, for example, if you are trying to find the correlation between the high calorie diet and diabetes, you might find the high correlation of 8, no? Or 0.8, sorry. However, you could also get the same result with the variable switch around. So in other words, you could say that diabetes causes a high calorie diet. And the obviously makes no sense. Therefore, as a researcher, you have to be aware of the data you are plugging in. So in addition, the person-product moment correlation will not give you any information about the slope of the line. It only tells you whether there is a relationship. In a real-life example, no, person correlation is used in thousands of real-life situations. Let's say, for example, scientists in the Philippines, for example, wanted to know if there was a relationship between how weedy rice populations are different genetically. So the goal was to find out the evolution potential of the rice. So person correlations between the two groups was analyzed. So it showed a positive person product moment correlation of between 0.0783 and 0.895 for weedy rice population. And this figure is quite high, which suggested a very strong relationship. So that was an example of the coefficient correlation, specifically the PPMC actually. No? I don't know if I could able to play. I will share to you the sample query using Microsoft Excel, no?
From statisticshowto.com, and in this video I'll be showing you how to find the Pearson's correlation coefficient in Minitab. I've entered my data into a worksheet. I've got 6 subjects with their ages and their glucose level, and I want to find out if the age and glucose level are correlated. So after you've entered your data, click Stat, Basic Statistics, and Correlation is towards the bottom. I'm testing my ages. Click the Select button and the glucose level. Hit Select. I'm keeping the p-value box checked because I want to find out the p-value as well. Click the OK button, and your results will end up in the session window, not the worksheet. And there's my Pearson's correlation. I've got a correlation of 0.530 and my p-value is 0.280. That's how to find Pearson's correlation coefficient in Minitab. This is Stephanie from statisticshowto.com.
Okay, so this will be actually an example on how you'll be able to get the coefficient relations. Okay,